This video is made to help you understand how partition walls go up. It's going to be a fairly long video because there are a lot of details to talk about here, but before I get into that, I just want to point out that there are really two kinds of partition walls shown here. You're probably going to choose one or the other. This is a wood frame partition wall, and this is a metal framed partition wall. It doesn't really matter if you use wood for partitions in the basement, because this wood is completely isolated from any source of moisture. So if you prefer to work with wood, if you've done it before, then there's no problem there. Metal is sort of a different process, working with metal studs and tracks, but there's nothing complicated about that either. So the first thing you're going to want to do is to measure the length of partition wall you want. So this is the total length, in this case extending from a perimeter wall right to a post. Now, I've located a post here in this illustration to show you how hiding a post within a partition wall is a great thing. The bottom plate, there's actually two. This is the bottom plate here, and this is what I call the base plate. More on those in a minute, but they both stop here where the support post is, and then the next wall, the rest of the wall is going to continue on later. So you don't need to sort of do anything fancy to wrap those plates around the post. The plates can stop and start again, and whatever wallboard you put over will span that, and magically that support post is going to disappear. So that's one way to deal with it. Now, in the instructions in the course, the whole partition wall thing is broken down into steps. And so I'm going to go through those same steps here. So what I mention as step 1 and step 2 in the video corresponds to the write-up that you can read about in the course. So step 1 is to just measure the length of wall you need, and you don't have to be very tight about it either. I mean, for instance, there's a distance from the wall here to the post. It really doesn't matter if that's a particularly tight fit or not. I would cut the top and the bottom plate about 1/4 of an inch less. It just needs to fit in there. There's no points for extreme accuracy or precision or anything like that. You just need to get some the base plate, bottom plate, and top plate cut to the right length so it's going to fit in there. Now, earlier in the course, I mentioned how I recommend using plastic lumber as a bottom plate for partitions. This gets the wood up off the ground. It acts as a moisture barrier, so this wooden bottom plate here stays perfectly dry. If you want to go to some extra trouble, and I think it's probably worthwhile, every so often you can cut grooves in this plastic bottom plate. I've only shown one here, but you'd probably want one every couple of feet at the most, and that's to allow drainage of water if there's any leaked water. Because don't forget, one of the advantages of the subfloor tiles is that they're raised up a little bit off the ground, and the system can tolerate a small amount of leakage. But of course, if this floor is sloped towards a floor drain somewhere, but you don't have these grooves here, then it's going to act as a dam, and it's going to stop the natural draining of water. That's not to say that the water won't go away on its own, because if the concrete floor is not painted, concrete's porous enough that eventually the water will kind of seep through. So it's not the end of the world if you don't cut these things, but it is recommended. It is a good idea. Step 2 in the process is more of an exploratory thing, and it involves measuring how high the wall needs to be. So that would be to extend between the floor and the underside of the joists up above. Now, you're going to discover a couple of things. Most commonly, the figure of the wall height from, say, this end to this end can vary quite a bit. It can easily vary 1/2 inch or so, depending on how the concrete floor was finished. So that's really what you're trying to determine now. How much does this floor vary? And you can mark the total dimensions here along the floor where you take them. And that's just mostly so that you know what you're up against when you move on with some of the other steps. Because the key thing, the main thing, is that you make the overall wall assembly the right height to fit in there. And the right height is not necessarily completely tight to the underside of the joists. And the wall height should not vary along its length either. There's no point in trying to make parts of the wall taller and shorter, and it's a big pain. It won't work, and it doesn't really pay off. So take your time now to measure the wall height, and then just record your findings here on the floor, wherever you take the measurements, as a reference for steps coming up. Step 3 involves cutting all 3 plates to length. They're all the same length, and you need to cut them now because it's important that you have them on the floor and sitting where they're going to be in order to measure the length for the wall studs properly. Step 4 involves, as I said, cutting the studs to length, but you want to do that first by stacking all 3 plates, so the top plate, the bottom plate, and the base plate, on the ground where the wall is going to be. And then you want to measure up from the top of that stack of plates to the underside of the floor joists. Now, what you discover here should correspond with what you discovered earlier when you measured for total wall height. And by that, I mean whatever area of distance is taller or shorter, you should be seeing the same thing, just to make sure that you're, as a double check, to make sure that you're measuring correctly. But because the wall studs fit between the top and the bottom plate, you can sidestep a lot of error-prone math by not using any math at all. You just stack the plates and you measure the height that the studs need to be in order to fill that space using a method that I showed you in a previous video, where you're not actually measuring with the numbers on a tape measure. You're just extending the blade and then locking that tape measure in position, locking the blade when the tape measure is extended enough to fill the space that you're trying to measure. Now, in this case too, you want to make sure that the wall studs end up being maybe 3/8 to a half an inch shorter than necessary to completely fill the space. This does 2 things. The main thing is that it gives you a little bit of leeway so you can tilt the wall up, because a wall that fits snugly between the bottom of the floor joists and the floor, you will never be able to tip that up, because when it's angled and in the tipping up position, it's a little bit taller than it's going to be because it's on an angle. So the leading edge of the top plate is going to hit the joists before before the wall becomes plumb, straight up and down, and gets to be as functionally short as it eventually will. So step 4, measure for those wall studs and cut them to length. Now, you can do all this cutting with a handsaw. A good handsaw is not a terribly impractical option, but this work right now is exactly where you would use a chop saw, also called a miter saw, just for straight cross cutting. It's faster, you're going to get greater accuracy, and with all the cross cutting you need to do when finishing a basement, getting a chop saw, even a very basic one, is actually a great idea, and this is where you're going to start to use it in earnest. Now it's time for step 5, which is marking the top and bottom plate so you know where wall studs go. Now you don't need to mark the base plate or the bottom plate because it's just sitting against the ground or on the floor, and it's going to be secured there. But you do need to know where to position the studs. So you should temporarily clamp or use some deck screws or something like that to join the top and bottom plate face to face. So it's essentially two plates, one directly on top of the other. And then you roll that over on its side, and you mark where wall studs need to go. Now, of course, there needs to be a wall stud at the beginning of a wall, and there needs to be a wall stud at the end of the wall where it meets another wall, or in this case, a support post, or maybe a doorway opening. That's another place where you might stop a wall. And the wall studs also need to be 16 inches apart. And when I say apart, I don't mean the distance between this face here, for instance, and this face here. What I mean is the distance from the middle of a stud to the other middle of a stud. In the carpentry trade, that's called on center. So it would be 16 inches on center. And the idea with the 16 is that it's a multiple of 48, and that's one of the standard widths of building materials. But they all do go in increments that will land on the middle of a wall stud. So if you're putting down some wall board or paneling or drywall or anything, you want the edge of the sheet material to automatically land in the middle of the stud, so that you can have the end of one sheet material stopping here and then the other piece of sheet material starting there. It's just a way of economizing, and it helps things to go together more quickly. So just to recap, you're going to want to mark both top and bottom plates at the same time so that the numbers correspond. And then you separate these plates in preparation for actually fastening the wall frame together. Step 6 is next, and that's all about assembling the wall. So this happens on the floor. The bottom plate is resting on its edge, so not on its flat like it's shown here, but on its edge. And the same with the top plate, and then the wall studs fit in between. Now I should mention that this wall is just an ordinary wall here. Earlier in the course, you will probably remember that I introduced you to the idea of staggered studs to help with soundproofing. So if the bottom and top plate were 2x6, then the intermediate studs would be 2x4, and they would be staggered. One tight to one side of the plate, the next stud over tight to the other edge of the plate, back and forth like that, so there's no continuous wood from one side of the wall to the other. But just for this video, I've kept things simple. You lay everything lying down, and then you drive some nails or screws to join them. So if you're dealing with a 2x4 wall, 2 screws or 2 nails will do. If it's a 2x6, you might as well use 3. You'll find that, especially if you're a beginner, it's easier to stay accurate if you join these pieces of wood with deck screws instead of nails. So 3.5-inch deck screws work quite well. And the reason is because you're not blamming away with a hammer, which tends to throw the alignment of parts out of whack. So you can hold with one hand, hold the parts together with one hand, align their edges, and then drive a deck screw in. And once that screw's in place, everything's held tight, and you can proceed easily with another. Framing with a hammer is a little more tricky because things do tend to jump around. You could also frame with a nailing gun too, which is faster than anything else and every bit as accurate, except that you can't really take the nails out. Sometimes it's nice if you get things wrong, if you're a beginner and just starting out and a little tentative, sometimes it's nice to be able to back that screw out and fix that stud that accidentally got put together not quite as it should. So I'll leave that up to you. This is not a structural wall. Either nails or deck screws will work just fine. Now it's time for step 7 in the written instructions in the course, and that's all about securing this bottom plate or the base plate. If you remember, I recommend either composite deck lumber or plastic. Composite is a 50-50 blend of wood and recycled plastic, and plastic is just 100% plastic, but either one is going to work fine for this. And so it's time to secure this. Presumably you've marked where it goes using some of the methods that I explained earlier for positioning this wall square to any neighboring walls. And when it comes to securing this, you've got two tactics, really. The first is to apply some construction adhesive. And as I've mentioned before several times, PL Premium is really the best stuff I've ever used. It's a polyurethane construction adhesive. It dries really hard and very strong, and I've never seen any other construction adhesive compare. A construction adhesive it comes in a caulking tube, and it's fairly thick, and it looks like caulking, but it hardens and gets sticky. So when it comes time to actually securing this bottom plate, you put on some construction adhesive and nestle the bottom plate down. Now, you're going to need to fasten it down too, because that bottom plate's going to squish and move and slide all over the place with the construction adhesive in place. So you can just fasten it with one fastener at each end, and you could use a Tapcon screw, which I've told you about before, and that's what you see here. These are screws that thread directly into holes in concrete without the need for any kind of an anchor. You could also use a powder-actuated tool, which is like a little gun that shoots out hardened nails that can go right into concrete. Now, as I said, you will need to secure the bottom plate at both ends so that it doesn't move around. Don't forget, at this stage, the wall is assembled and it's lying flat on your floor. The next step after securing the bottom plate will be to tilt that wall up, and you can't have this bottom thing sliding all over the place. So you will need to secure it and get it in position. So step 8 is when you tilt the wall up, and this is when the accuracy of your calculations count. That wall should just tip up without touching the joists up above, or maybe touching them a little bit. You might have to nudge the wall into position a bit. But there's two things you want to accomplish when you tilt that wall up. First, that the bottom wood plate is aligned perfectly with the composite bottom plate. The composite bottom plate kind of calls the shots. And the wall itself needs to be plumb. And to make something plumb, you need a level. The plumb is just straight up and down. So the level will tell you when that wall is straight up and down. You're going to want to measure it first here at one end, and then at the other. And then you'll get the wall close with nothing fastening it. When everything looks pretty good, put some fasteners in to fasten this bottom wood plate right through to the floor underneath. One option is these expanding metal anchors. Imagine a bolt with a nut on it, but no head on the bolt. So you drill a hole through the wood, the composite, and into the floor of the right size to match the anchor. And then you tap the anchor in place with the nut all the way up at the top. And then you tighten the nut. And in the action of tightening the nut, the anchor swells up inside the concrete floor, and that's how it grips. You could also, if you could find some Tapcon screws long enough, you could use Tapcon screws that go all the way through. You could use some powder-actuated fasteners that go all the way through. You're going to need to do something like that. One of these three options, the powder-actuated option, the expanding metal anchor, and the Tapcon screws, are what you've got at your disposal. And just to make sure everything works fine, that construction adhesive is going to be giving a pretty good bond to the floor underneath, so that wall isn't going to go anywhere. Now, with the bottom secured, you can get serious about plumbing the wall. So I would start at one end, put your level on it, and prepare yourself to anchor the top of the wall to the bottom edge of the floor joists. Now, as I've mentioned before, there's a little bit of a gap there between the top of the wall and the joists, intentionally so, and you'll want to fill those with wedges, wooden wedges. You can buy them at building supply outlets. You can buy a couple of packages of cedar shingles. They're tapered and they're wood, and you can slice the cedar shingles to width. But wherever there's a floor joist, and you're going to want to drive some screws through the top plate of the wall into the bottom edge of the joist. But first, you want to fill the space with these wedges. And by pushing the wedges more or less in or out, working as a pair like this, you can get a custom fit so that all that space is taken up nicely, and then you drive the screws, and it's all perfectly tight and works super well. I always like to put a little bit of wood glue on these wedges on all surfaces. So this surface here, the middle surface where the two touch, and then further down, just kind of slather that on and install the wedges and drive the screws. And when everything's dry and the glue's hard, you can use a handsaw or a chisel to knock off the excess here. But you're going to get a very strong, solid installation that way. And as you work along the wall, use your level on each stud. Just because the wall is plumb at one end and at the other doesn't mean that it's plumb all the way through. So pay attention to that level, and you'll have a nice wall as good as anyone could have built it. Now, if you've opted to use metal studs, the process is a little bit different. Notice up top here there aren't any wedges, and there are over here with the wood wall. And that's because a metal stud frame wall is put up piece by piece. So the bottom track is fastened to the concrete floor. You're going to want to use a construction adhesive. Tapcon screws are definitely best for this. They're superior to the other two options. And you lay that down, secure it, and then you fasten the top track in place. You'd use a stud at one end and a stud at the other, along with your level, to determine that the top track is exactly above the bottom track. And when it's secure, then you put in the wall studs one at a time. So you're cutting them to fit that particular spot. You're tilting them in place. You're putting it in the track. You're tilting it up. And then you secure both ends of each stud with two screws, one on each side. The screws can go right into this metal. The metal's not very thick, and it's designed to have screws go into it easily when driven with a drill. So it's a pretty simple operation, and you just put on one stud and then the other and work your way along with the proper stud spacing, as I explained before. Now, there's one other thing that I want to mention, and it has to do with this blocking up here. When you're installing walls like this, you're going to need to put in some blocking so that there's always a solid place to anchor the ceiling pieces, drywall probably, or it could be some other kind of paneling. But the edges need to be fully supported, and that's where this blocking comes in. It can be 2x4 or 2x6. You might not be in a situation exactly like this. Maybe your wall here is parallel to a joist, and maybe it just sits. The wall sits between a joist and it runs in the same direction as a joist, which means that you'll have to put on some blocking like you see here to fasten the top of the wall to. In this particular situation, we're fastening to the bottom of the joists, but if the wall fits between the joists and is parallel to the joists, you need to put in some blocking like this ahead of time. And in a case like that, on the top of the wall, you'd also want to put some blocking so it extends past the top to create a nailing surface for your ceiling sheet material. So always keep that in mind. Ask yourself, have I created a solid backing to support drywall and things in corners? Because in addition to creating the partition walls, now's the time to think like that and to install the blocking that you need.